Calculus, Unit 6, Day 50 notes. Our objective is to learn and apply the fundamental theorem of calculus, Part 1. Okay, so let's take a look what the fundamental theorem of calculus tells us. This is Part 1. If f of x is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then the integral of f of x dx from a to b is equal to f of b minus f of a, where f of x is the antiderivative of f of x. So this is like the derivative, and then this is the original function. So again, it's going backwards. Okay. Now we're going to look at some examples. Same example. So consider the function f of x equals negative 2x plus 3, whose graph is pictured below. Calculate each of the following definite integrals according to the fundamental theorem of calculus, then shade the area of the region that the integral represents. So what we're looking at here, we're looking at over the interval from negative 2 to 1. So if I just did this, and I shade that in, because we're looking at, this is the 2x, negative 2x plus 3. This is the x-axis. So we're saying the integral is the area between the function and the x-axis. This ends up being a trapezoid. Hey, we know the trapezoid is 1/2 the this height, which again, if I picture this as being um, this height right here is down there. So if that's the height, and then here's my base 1 and base 2. Um, that would be base 1 up here. And then this is base 2. That's base 1. That'd be base 2. So the height is from negative 2 to 1, so that's 3. And then the sum of the bases is going to be, that's when x equals 1. Negative 2 times 1 is negative 2, plus 3 is 1. And then I go to negative 2. Negative 2 times negative 2 is positive 4, plus 3 is 7. So area equals 1/2, 3 times, oh, this supposed to be 1/2. 3 times 8, 3 times 8 is 24, half of that's 12. Okay, well, we're going to look and see what this definite integral gives us. So what do we know? Let's take the integral, antiderivative. So I add 1 to the power, so it's going to be negative 2x squared, and then we divide by that power, 2. Um, add 1 to the power, so it's 3x the first, all over 1. We have to add, oops, sorry, we have to add the constant. We don't know what it's going to be. Oops, sorry about that. And we're going to evaluate this from negative 2 to 1. And I need that to stop doing that. So when I do this, I'm going to substitute in the upper limit. And for the upper limit, I get, I put a 1 in, so I'm going to get 1 squared is 1. So I'm going to get negative, and then it's going to be 1, because 2 over 2 is going to be 1. So then it's 1 squared plus 3 times 1 plus c. And then we're going to subtract. And when I subtract, we put a negative 2 in here. So I'm going to get the opposite, because don't forget that negative sign there. Negative 2 all squared plus 3 times negative 2 plus c. And I'm going to see what happens to the c values in a second. So 1 squared is 1, so I get negative 1 plus 3 plus c. This negative sign is going to be distributed to everything in there. Negative 2 squared is positive 4. The opposite of that's negative 4, but then we distribute that negative sign, and it's going to be positive 4 again. 3 times negative 2 is negative 6. Distribute that negative sign, we're going to get positive 6, and this is going to become negative c. So our constants are going to end up canceling out, and that's always going to happen because we're finding the definite integral. And then negative 1 plus 3 is 2, plus 4 is 6, plus 6 is 12. And I need you to write right here. There we go. And let's try that again. Sorry about that. And I notice that I get the same value that I would have if I just took the area of the trapezoid. And we're not always going to have the picture to help us, and some of the functions are going to, again, it's much easier when it was a trapezoid. We're not always going to have a trapezoid. And again, this goes back to our fundamental theorem of calculus. So if f of x is continuous on the interval and differentiable, then the integral of the function on the from a to b is equal to the value of the function from the high end minus the value at the low end, where f of x is the antiderivative of little f of x. Okay, so let's try the second example here. I'm going to do this out, and then we'll go over what we got. Okay, so we know the antiderivative is, and I'm just going right up here, negative x squared plus 3x and plus c. And then I know I'm going to get a plus c and a minus c, and then those are going to cancel out. So what we've done is we've just left them out. So when we're doing a definite integral, we don't need to do those anymore, the constant of integration anymore. So as we go through, we first put in f of b, which is the upper limit of the integration, and I get negative 25 plus 15, then we put in the 2, it's the lower limit of integration, and we get negative 12. And if I did it the old-fashioned way, I get negative 12. So this shows us how to find the integral, which represents the area from the function to the x-axis. If it's a value above the x-axis, it's positive. If it's a value below the x-axis, it is negative. Thank you. And that's going to be it for part one. We'll do some more of these examples in part two. Thank you.